This is video 22.2. We will be looking at the EMF induced in a moving conductor. The question: a metal bar is moving down a U-shaped piece of wire, making a loop of changing size. Assume the magnetic field is 0.24 Tesla and the bar is 80 centimeters long. If the bar travels at 10 meters per second, what is the induced EMF in the loop? And if the loop has a resistance of 0.4 ohm, which is constant as the loop changes size, how much power does it take to move the rod? First, we'll calculate the change in area per unit time. The change in distance of the bar per unit time is V delta t. This we know from ordinary kinematics. So the change in area of the loop as the bar slides to the right is L delta x, which is, in terms of time, LV delta t. Now we can find the change in area per unit time by dividing both sides by delta t. Now we'll calculate the change in flux per unit time. This is simply B times the change in area per unit time, because flux is simply B times A for a spatially constant magnetic field, and a magnetic field which is perpendicular to the loop. Altogether, this is BLV. Now we're ready to calculate the induced EMF in the loop of wire. Using the same formula we did in the previous video, and using n equals 1 because there's one loop of wire, we have this simple formula for this geometric setup of a bar moving to the right inside a perpendicular magnetic field. If we plug in the values that we were given in the problem, we find E to be minus 1.92 volts. Step 4 will be to calculate the power needed to move the rod. It's moving at a constant velocity, so there's no power required to accelerate or decelerate the rod. The only power used is in moving the electrons through the loop of coil, which has some resistance. But this we know how to calculate. The power is equal to IV. We haven't calculated I, but we know it's V over R using Ohm's law. We were given the resistance at the beginning of the problem and we just found V, the induced voltage. Putting this together, we find the power needed to move the rod is 0.92 watts. And that concludes video 22.2. Check out PhysicsX on the app stores. This revolutionary physics app for smartphones and tablets contains over 100 videos and 500 multiple choice questions designed by education experts. It's been proven to improve scores for intro college physics, AP physics, MCAT physics, and more. Just look for the blue icon.